Alright class, it's me again, lesson 5.5, question number 39, a little bit of homework help for you. And let's see, what does this one ask? It asks us to use the half angle formulas, which I've copied out here for you. They're on your formula sheet. And it also says to determine the exact values, which means no decimal approximation. No decimal approximation of the sine, cosine, and tangent of the angle. So that's like 1, 2, 3 different things to do. Okay, now this example happens to work out really nicely because if theta equals 15 degrees, well, that means 2 theta equals 30 degrees. And this one we don't know because I'll say it's not on the unit circle, but this one is on the unit circle. Okay, so that's kind of where these half angle formulas come into play. See, the problem is we don't know theta, but we do know 2 theta on our unit circle. So we can play with this a bit, okay? So let's basically just use the formula. It tells us to use the formula, so let's use it. It says the formula is sine squared of theta, which is 15 for us, degrees, equals 1/2 1 minus cosine. Now 2 theta is going to be 30 degrees, and that's it. But the nice thing is we know cosine 30 degrees. Here's the unit circle, and here's 30 degrees. So the cosine is the x-coordinate. That's √3/2. So that's what we care about. That's the cosine of 30 degrees. So we have sine squared 15 degrees equals 1/2 1 minus square root 3/2. That's cosine 30. Okay, so we're pretty close, but the thing is we're not looking for sine squared, we're looking for sine. So we need to take the square root at some point, and we also need to do some simplification here. So I think I might first just bring this in 1/2 in like that, minus √3/4. Okay, and then we can simplify that again. Let's add the fractions together. 2/4 minus √3/4. So that gives us in total 2 minus √3/4. Okay, and that equals sine 15 equals this. Okay, but we don't want sine squared. We want sine 15 itself. So let's take the square roots of both sides. That gives us sine 15, and that gives us the positive and minus square root of 2 minus square root 3/4. Okay, now we can go a little bit farther because the square root of 4 we know. So the denominator is 4, so we can write that again as positive and minus, I'll just put it this way, 1/2, because that's 2 is the square root of 4, that's where this comes from, and then we're still left with square root of 2 minus √3. Okay, so we're practically there, but there's one last detail I want to focus on here. And that is, think about this angle, 15 degrees, right? Well, on the unit circle, that would be in here somewhere, 15 degrees. And we're trying to find the sine of 15 degrees. So that's the y-coordinate of 15 degrees. Well, if it's the y-coordinate in 15 degrees, you can see the y-coordinate right here. We can say the y-coordinate is positive. Or another way to, if you remember that all soup tastes cold rule, well, we know that all angles, all ratios are positive in the first quadrant, so sine must be positive. So basically it's a long way of saying we don't care about the negative. It can't be negative, it has to be positive. So let's write the final answer as 1/2 square root 2 minus √3. Voila, finished. And I think I might leave the other ones up to you. I might make another video if people are having difficulty with this, but I'll leave you to try to finish off cosine doing the same type of method and tangent as well. Okay? So, enjoy. See you later.